Okay, good morning, dearest. This is Professor Mhoz Denis Kafaras, Afritech University of Aeronautical Sciences, and today I'm taking you gas turbine engine constructional design. As you can see the date, then this is 2020. Yes, should not confuse you. And duration is, I will not take 2 hours, but practice should be 2 hours. I'm just going to take around 10 minutes or 3 minutes to deliver this presentation to you. Turbine engine construction design. So we're going to look at a gas turbine engine and how it works. So a significant feature of the gas turbine engine is that a separate section is devoted to each function. All functions are performed simultaneously without interruption. So unlike a piston engine whereby combustion, compression, exhaust and intake all take place in the same chamber, combustion chamber, in the same chamber, so that's the cylinder chamber. Here this is different in gas turbine. We have a separate section for inlet, we got compression, we got to combustion, then exhaust, all taking place at the same time without interruption. So a typical gas turbine engine consists of the following. We have an inlet, air inlet. We have compressor section. We have a combustion section. We have a turbine section. Exhaust, accessory section. And then we have the systems necessary for starting, lubrication, fuel supply, and auxiliary purposes such as anti-icing, cooling, and pressurization. We shall look at all this by the end of our topic, gas turbines. So the major components of all the turbine engines are basically the same. Mr. Professor, you're saying that. How is it that? The greatest single factor influencing the construction features of any gas turbine engine is the type of the compressor. That's whether axial flow or centrifugal flow. I can take you through how the axial flow engine looks like. I think the diagram clearly explains. So we saw the main parts. So we have an inlet, we have a compressor, we have other auxiliary functions related with engine lubrication. We have the engine oil supply, and then we have the accessory case. You have the stainless steel fire seal. Yeah, because there's a lot of high temperature, so it must be protected from fire. Then we have the engine mounting, where we use to mount our engine. So this is the combustion section. Here we have the turbo compressor, that's the compression section. Here's the exhaust section. Okay, we proceed. Now we see centrifugal flow compressed engine. Of course, we are looking at what is the difference, what effectiveness between the two types of compressors. We said that the main factor influencing the construction of a gas turbine is the type of the compressor, whether axial or centrifugal. But here we have centrifugal flow. We saw here we have the accessory case, we have the air inlet, the compressor, diffuser, combustion chamber, turbine, then the exhaust duct. You notice that differences that there is a difference in the length and diameter of centrifugal and axial, whereby the axial compressor is long in length and smaller in diameter compared to the centrifugal. So now we go to the air entrance, because you're looking at the main parts of the comb of the gas turbine. We have the air entrance, that's for air entry. So air entrance is designed to conduct incoming air to the compressor with a minimum energy loss resulting from drag or ram pressure loss. That is, the flow of air into the compressor should be free of turbulence to achieve maximum operating efficiency. So this is done when we are constructing the entrance. We have to make sure that it can conduct incoming air to the compressor with minimum energy loss. That energy loss is brought about by drag or ram pressure. So when I ask you about the energy losses in air entry, you have to know there is drag, then there is ram pressure. So how does it do it? It makes sure that the air flowing to the compressor should be free of turbulence. It should not be turbulent, it should be orderly. We have the cold section, the hot section. You can see the combustor is part of the hot section and exhaust. So in the cold section we have the air intake, then we also have the compressor and the diffuser section. So the amount of air passing through the engine is dependent upon three factors. Air passing through the engine depends upon three factors. 1, compressor speed. 2, the forward speed of the aircraft. Then 3, the density of the ambient surrounding air. So compressor speed, forward speed of the aircraft, and the density of the ambient surrounding air, they affect the amount of air passing through the engine. So you know this compressor speed, forward speed of aircraft, and density. The inlets may be classified as, we have nose inlets located in the nose of the fuselage or powerplant pod on a shell. Mr. Professor, there are other inlets classified as wing inlets, annular inlets, scoop inlets. Can you tell us how they are? Yes, wing inlets are located along the leading edge of the wing, usually at the route for single engine installations. We have annular inlets and they are encircling the whole of the fuselage or part of the fuselage or the powerplant pod or the nacelle. The scoop inlets project beyond the immediate surface of the fuselage or the nacelle. So they are like outside. Area is to scoop the air. That's called scoop inlets. Annular because they are in the hole, they are encircling the hole or part of the fuselage. And then we have flash inlets. These are recessed in the side of the fuselage, power plant or pod on a shell. So these ones are recessed, they are slightly in some car inside of the fuselage. So, Mr. Professor, there are two basic types of air entrances in use. Can you tell us about them? So the single entrance and the divided entrance, they are the types of the air entrances in use. And we shall look at how good each one of them is. So the single entrance with an axial flow engine, mainly it is on an axial flow engine because of its smaller diameter, and it's to obtain maximum ram pressure through straight flow. And then we have the divided entrance. It offers the greater opportunity to diffuse incoming air and enter the plenum chamber. Plenum is like a storage chamber with low velocity, required to utilize efficiently a double entry compressor. So a double entry compressor requires the incoming air to be at a low velocity. So thus it has a chamber where it first stores that air that is at a high speed and then it utilizes it. That's how each compressor is made. So thanks for watching our channel and thanks for tuning in to listen to the Mr. Professor. That was the end of engine constructional design, and we catch you again in our next topic. Thank you. Don't forget to subscribe to our channel.